Hello and welcome to podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, or TuneIn Radio, or add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, with links in the show notes. Please give us feedback. You can leave us a review on iTunes, send us an email, send us a tweet, or leave us a message on Google+, as well as leaving a comment on our show notes. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. I would also like to thank Hired, a job marketplace for developers, for sponsoring this episode of podcast.init. Use the link hired.com/podcastinit to double your signing bonus. Linode has also sponsored this episode, and you can get a $10 credit using the link linode.com/podcastinit to try out their fast and reliable Linux virtual servers. We are recording today on October 6th, 2015, and your hosts as usual are Tobias, Macey, and Patti. Today we are interviewing Kay Hayen about the Nuitka project. Kay, could you please introduce yourself?
Yes, hello. Thank you for having me. My name is Kay Hayen, pronounced German. And, I'm a father of 2 kids. I own a cat, and I'm the author of a Python compiler. That's what I do as a hobby. For work, I am in the air traffic management. I work on a tracker, and I've developed to be a systems engineer in that product. So a tracker does take radar information and turns it into tracks, as you probably know all from the movies where the beam turns around. So, yeah, basically that is what I am.
Very cool. So how are you introduced to Python?
My brother originally started me with Perl. So he told me, learn Perl. He's 13 years older than I am. Learn Perl and you will be capable of doing things nobody else can do. And I was very deep into Perl and successful with that, and was actually using this in my current job 13 years ago. And then for the product, we made a team decision to move away from shell script. And we were reviewing our options, and Python was getting a lot of positive press, and we wanted to have a focus on readable because we are into safety stuff. Everything that we do gets reviewed and looked at, and reading it is the most important task to us. So Python seemed like a natural fit, and so I learned it for the job. So there was some reasons not to want Python then. It wasn't as complete as Perl was. Complete in terms of the ecosystem for Perl. Everything existed that now exists for Python. So that was about to change, and I have never regretted that decision. Actually, I fell much in love with it. So I learned it on the job.
It's interesting how many of our guests have cited moving from Perl as their introduction to Python and wanting to move to something that was more readable and understandable.
There was this mantra of Perl, there's more than one way to do it, and it felt really right for a long time. So you would have this natural language expression. It would feel so natural to code. It feels so fast. But the thing was, I couldn't understand my own programs from 6 months ago. So that was not a huge success when thinking of working as a team on this. Although some people did, but I think we were and are very successful with Python. And like I said, I think when you've done Perl, you get to fully appreciate the readability decisions that Python made. It's just the opposite end of that.
So, can you briefly describe what Nuitka is and your motivation for creating it, as well as where the name came from?
Yeah, of course I can. My wife is called Anna. I one day I made her a gift. It was a compiler, a Python compiler, and I named it after her. She's Russian. And the Russians have this tendency to not use the real name, but extensions of it. So they would always attach something at the end. And in her case, it's Nuitka. And then we shorten it again and say Nuitka. So that's that. And the form it's written the alphabet, the English alphabet maps very strangely to the Russian one. So you can take this as my attempt to confuse the world. And last Europython, somebody said I could have made it a whole lot easier to name it Anna.
Yes, but then it wouldn't be nearly so cool, because I just got to say, I think that is an awesome name with an awesome story. And speaking as someone who is very enamored of my wife, I think that is just fantastic that you chose to name it after her.
Yeah, it's a very romantic present. I'm sure she appreciated it.
Yeah, it did. I mean, if you marry, I'm like I don't know if geek is a word to describe yourself, but I'm totally into programming and this kind of things. And so if you're crazy enough to marry a guy like that, you have to be tolerant of these kind of things and appreciate that. And that works pretty well. So
yeah, my wife can definitely relate to that as well.
Mine too.
So I named it after her, and the thing was working with Python in this somewhat serious setup. What I've done there is we created a middleware that is using Ada. The product we have is mostly written in Ada and Python, and it's not just for unimportant things, but relatively soon we integrate it into the live product and do real stuff. So in the middleware, some of the components are pure Python and not pure Python. They're linking to Ada libraries. And that's pretty much an achievement. And we are very much into thinking about is this reliable? So Ada is the most type strict language that I know of. It's easy to make integers that do not mix. For example, if you have X and Y coordinates, you can make these different types, and you just cannot easily use them in operations without casting them. So it's very much more strict than, say, C++. And on the other hand, we have this full and total type-aware language, Python, but it's not strictly checking. And that leads to all sorts of problems and, of course, limitations on the performance side. So this has kind of driven me into thinking about, couldn't it be any other way? So I was for a long time thinking, well, no, it's not possible. And then I turned into, well, it ought to be possible, but then why is nobody doing it? And the more I learned about Python and details, I thought, well, it could be done. And I was checking with other projects like Pyrex was a very early candidate, Psycho, a JIT compiler, then Pyrex. And Cython, I produced patches for Cython as well as for PyPy. I looked into these things, and doing that, I kind of realized I can do something that can be a fully integrated and compatible compiler. So PyPy, for example, has a drawback is that you can't just use Qt with it. There's always going to be adaptation because the extension modules don't work, and PyPy is not fully exactly the same garbage collection that CPython is. And your programs, I can't just take a million lines of Python code and run it in PyPy and expect it to work the same. And so it's not feasible to migrate to that, or Cython doesn't want to have to the full, at the time it didn't want to be fully compatible with the language, not even complete with the language support. It now is. But I thought I can do it, and after a while I decided I am doing it. So what I did was first a proof of concept toy compiler that I announced on the Cython mailing list. And quickly, while doing this, I realized that I can drive this forward and make a solution that I think the market, if I can say that, wants. More generally speaking, what I'm doing there is also to think out of the box, to take Python where it is currently not used. My interest there is not to enhance any existing use case that I have, but to take it to where it isn't currently. So if people were needing a Python compiler, they wouldn't be using Python. So from the existing user base right now, most of them, except maybe scientific people, don't need it. And I want to get the Python community to be rid of having to make these hybrid things that I did for work. So having to do some things that need to be fast in one language and the other things in another language, that is just a lot of overhead, and it felt like that should not be needed. So simple code should compile to fast code by default, and complex code should still work. That's an overly ambitious goal. It's even insane. I would say, well, there's some likeliness that it's impossible to succeed. But with the years, I think I have reached a point that I think I've proven it's possible to succeed. And yes, I will say more later on. So brief description is I was thinking there's a couple of corner solutions there, and I wanted to have a fully sustainable solution that has all the scope. So the over-ambitious Python compiler, if you want to say that. Yes, that's the thing is also I didn't need this to succeed, so I did this as an experiment. When I started, I was not so sure how far I can get with this, especially with the compatibility. But right now I see that people are very confident dropping very large code bases into Nuitka and having it just work. That's the thing that I think it's very important that you can have these million lines of code and expect it to work the same way it did before. Yeah, so much about that.
So on the project website, it says that Nuitka does a lot of clever things after being fed a Python project, and I'm wondering if you can provide some details as to what some of that cleverness is.
Yeah. I'm pretty sure that this clever wording was kind of a crowd effort. So it's probably not my own word, because that's for a long time I was thinking it's not very clever. But so it does two things. One important thing is reformulation. So when it works on your Python code, it sees this high-level language construct, for example, class statements or assertions or complex statements, complex assignment statements. And for example, a class can be created by calling the type built-in and giving it as an argument the name of a class, the base classes, and a dictionary. That's what this class statement is effectively doing. With a class body that you see is assigning local variables in a function and then returns locals for this dictionary to use. So I would have these sort of reformulations. Same goes for meta classes. In case of meta class, you wouldn't call type, but the meta class. And a lot of the language of Python goes away, and actually Python as its core can be represented in a much simpler Python, and then I'm compiling that. So for example, if you assign A, B to C, D, there is a series of assignment being done to temporary variables first. Try finally with deleting on these temporary variables and then assigning from the temporary variables. For example, that's a reformulation, and you end up with a language that only has simple assignments, for example. So these reformulations allow it to sometimes discover that part of the overhead of doing this can be removed, because it's already clear what that dictionary is, or the temporary variable can be predicted. These kind of things, and then Nuitka can throw these away. Then something I've been working on literally for years is, I maybe want to talk about this on another question, but it does tracing, and the tracing attaches assignments to use sites. And the code control flow in a language with try finally is pretty nasty, because you can exit code control flow or try except similarly. You can exit control flow in a lot of cases and join at other ones. And getting that right was sort of difficult, especially together with loops. So it traces these things, and then it knows what it is or what it's being, is it assigned or isn't it assigned? So it's a lot of checks that you can just not do because you know statically, whereas a Python runtime, the normal Python runtime, is agnostic of these sort of things. Nuitka with its traces will know that, for example, a parameter variable must be assigned, whereas a local before being assigned isn't, that kind of thing. Also more complex stuff just works and helps it making these determinations or even finding out about exceptions statically. Then it does something that I've demonstrated at EuroPython this year, function inlining. That's in a coming release. I have this only as a prototype code that I feel it's not general enough. And it does simple things like constant propagation. So, for example, what we like to do is we like to give constants names, like, for example, the amount of meters in a nautical mile. You can write down the number and leave people guessing what this means. And that's actually the fastest code. Or you can assign a variable to that constant and then use that variable. And that's an extra cost. And one of my goals is that what I've observed is that people, as software developers, when they know that this is slow, it's somehow in their head, and I want to get into the head of a developer and tell them, no, readable code is not slower. That's one thing that Nuitka can definitely achieve. And another thing, for example, sometimes variables will be shared among functions, and then, but only in some times. For example, there might be a branch to dump something, and then that's deactivated and not run, and Nuitka will detect this and avoid the overhead of shared variables. That's the kind of things it currently does.
One thing I'm curious about is whether Nuitka operates at the textual source code level, or if it compiles the code down to the Python AST before doing its optimizations and transpilation.
Yes. I'm using the AST module from Python. So originally I started out with bytecode compilation of the source code. And I went back to source code because I felt like it will help me ultimately to have a better link to the source code. Precisely, the bytecode was never going to have a good link to the source code. So the AST module, basically Nuitka does import AST, ast.parse open file name read, and then walks over this and turns it into one of its own structures. So there you have with nodes, and Nuitka then reformulates some of these into other things. And it's pretty simple, actually. The parsing side is very easy. For a compiler, you have this part where you put the language into tokens and then represent it as an AST. And I'm just reusing the CPython implementation. So that's one of the benefits of not extending the Python language, is that this part is really easy and almost guaranteed to be correct.
And is the output of Nuitka a set of source files written in C or C++, or is it a binary output?
Yeah, that's a very interesting question. Originally, when I started this prototyping effort, I was largely interested in compatibility. I wanted to know if it's possible to get exec and eval to work, all the dynamic stuff. And the thing that got me started to think that this is even possible, that was the idea of doing this in C++, latest, greatest language standard. It was also an idea to somehow learn about what later became C++ 11. And the thing was that this was really simple code generation, where I could, for every node tree element, I just had some sort of C++ template and fill in a bit of values and have relatively quickly a demonstration that this works. Once I had that, I decided that I want to be faster. For example, C++ exceptions are extremely slow. So when you erased an exception on Python, the C++ exception was raised. And the funny thing is that Python exceptions are much faster than C++ exceptions. So I was like 10-fold slower if an exception raised. So that was not going to be a faster runtime. So I gradually moved away from using C++ exceptions. I moved away from using templates, classes. I went to C++ 03, and it took me 1 year to get rid of the real uses of C++. So now it's C++, but it's GoTo-ridden. It can hurt your eyes to look at it. It was very pretty. So I presented slides which were basically, you could almost recognize the original Python code, and now you can't. So structurally, logically, to my heart, it's C code, but I'm still using a few things only allowed in C++. So but it's supposed to go away. So it's going to be C, and it's going to be multiple files, yes.
So what is libpython, and how is it used in both Nuitka and CPython?
Yeah, libpython is the single reason why this project is possible for a single person. So I think it was in 2012 that I presented it first to EuroPython, and Guido said in his talk, answering the question why there is no Python compiler. He said it's not easy, and if it were easy, he would have done it. I disagree. I think Python is kind of prepared for that. It's sort of easy, and libpython is really what does this. It exposes the Python core, and the core is a virtual machine and a C interface for extensions. And what I've been doing with Nuitka is basically registering extension types with the core. And for one example of this would be, for example, the compiled function is very similar to a regular Python function and works largely as a drop-in replacement. So libpython allows me to for example, use the original integer type implementation of CPython and be good. So be compatible, you just do the same. It allows me to just have had a Python compiler that is just not having bytecode, but making C calls instead, and it works, which ultimately is what the Python VM does when it sees the bytecode. So technically, this is very important, and it's an important cornerstone of one of my strategy. The strategy being that I want to have graceful degradation. So when I had this compatibility milestones, what I wanted to be is compiling code and run it fully compatible. So the CPython test suits, for example, run virtually unmodified. They just work in exactly the same way, and then from there on, for example, I have this integer implementation of Python, a pyint. But for example, once I start to identify cases where I don't have a use it, but can get away with a C integer, for example, then I will just do that. And where things get too complex, where interaction with unknown stuff will be needed, I can fall back to libpython and be compatible. So that's, sort of my disagreement with Guido there is that I think actually a Python compiler would have been easy all the time. And after all these years, I've finally done it. That's the achievement there.
Well, and I'm quite sure that Guido is happy that you disagreed and that you chose to take it to the next level of actually implementing it, because it certainly benefits us all.
Yeah, actually, I got to talk to him about it, and it wasn't a warm welcome. Actually, he's not too fond of a project.
Huh.
That's interesting.
No, you can. It would be no exaggeration to say that he doesn't endorse it.
Why? Do you have any sense of why he has an issue with it?
No, that's a question he can answer. I can only make a speculation, of course.
Yeah.
But my speculation was that the thing about the well, let's suppose I'm getting this done. What it will prove is that an outsider, I wasn't part of the Python community at all. Once I prove it's possible, it changes. Well, it means like, had this been done 10 years earlier by a capable person, it might have changed the landscape for Python a lot. That's something that this may prove. Obviously, it's a large task for me. I might not make it to my ultimate goals, but I think it definitely proves the possibility of this. And I don't know. Nobody likes being wrong.
Right. Well, that's unfortunate, but thankfully, the world of open source is large, and you can go and do your own thing, and Guido can do his own thing. And
I used to say I didn't ask for permission, so this was also kind of like a surprise. Actually, I presented this, and he didn't know about this, so maybe that's also something that got him upset. And yeah, but I didn't ask for permission, and I received zero forgiveness. So that's the state of that thing. It's a bit unfortunate. I had expected him to ignore this, so because it's not really relevant until it's ready, and maybe it's never going to be ready. So yeah, so I wasn't expecting him to be upset with me.
Well, it's definitely an interesting exploration into what is possible and what it takes to make it become possible. So
yeah, it definitely is, and I'm going to ask people to join me. The thing is, it's limited by me right now, and I would need more people to help me. It's definitely, with more manpower, we could have this working already, but so far I've not managed to. The thing, what I've made out of this is that when I presented this, I was fully aware that at this conference, there's nobody there who needs a Python compiler. Nobody needs one. And so why would you do it? That's actually the reason why it never existed, is that nobody's really had that incentive. You can use C++ instead. You can do these hybrids. It's a well-settled solution. And my goals are too radical, I think. So for everybody else, I think they have got other stuff to do. So that's except of course maybe PyPy people. They don't quite fit into my equation, right? So because they're doing the same thing.
I'm sure that once it becomes production ready, that a number of people will change their tune and start flocking to it to gain extra performance out of their code at no extra cost.
Yeah, I mean, I have been having users for many years now, and some pretty big names among that. So it's being used in production, although I cannot recommend that. But I think even small gains mean something to some people. So we're going to talk about performance later more. But it's not much yet in terms of performance. There's not an order of magnitude to be gained, if anything at all, yet. So the user base clearly is there, but it's just different from. There's not a whole lot of people who actually can do these things. That's unfortunately true as well. So so that was already a lot of stuff.
So is there any way to provide type hints to Nuitka to generate more optimized output?
The idea that I have is like there's this PEP 484 that I don't like much. Everybody's asking about will Nuitka support that, and my answer is always yes. But it's unreliable type information. So the way I understood it so far is that you just add unused source code that could be used as hints to other tools. It's almost like a big form of comment. And if you ever worked on a large code base, you frequently found comments that were not in line with the code. So what's going to happen is that precisely that will be the case. So type hints will be wrong, and I can't rely on that. So currently it's not possible. The goal is definitely for this to be unnecessary, and I'm working more toward that end. And if there was anything like that, and I'm dreaming of a hints module, is that this would be implemented in pure Python, and it would work in pure Python, and my code analysis would identify that the thing that you're hinting at is definitely true because the code checked it. For example, if you want to give a hint that something is an integer, so you could write assert type x is int. Then the compiler will know from here on either erase an exception or it's definitely an int. That's the level of type hint that I'm looking at, pure Python code that just works. And for example, if you wanted to give me the hint that a module is not written to from the outside, which would allow a lot more static analysis, I would ask you to import something that wraps your module so that it becomes inaccessible to everything else. And then the static analysis is supposed to understand that. So I don't know if that's going to happen. Definitely it's a tough thing to make. I can see why these unused type hints are a good start. But I would prefer something more radical for hints. For example, if a function has a signature that it's only supposed to be called with integer string list, then check that when it's called, or make that at least an option. But that's nothing that exists, so I'm kind of disappointed with that PEP. Yeah. But right now, truth to be told is Nuitka doesn't use type knowledge at all yet. So integer, float, string, it's all the same right now. So that said, it's something I'm going to attack now that I have this SSA, the single statement assignment, under control. It's something I can only start right now. So working on optimized code for integers, floats, that's only something that will now begin. And so I have not invested a lot of effort.
And following on with that question, what are some of the biggest challenges in generating statically compiled code from a language that's as dynamic as Python?
Yeah, actually, that's to me, it is, Python is compiled. It's compiled like Java is compiled. It's compiled to virtual machine code. And the only difference really to something like Ada is not the instruction set that you use for execution, but the lack of checking types. And that's not really making it harder to generate statically compiled code, because all I'm doing is I'm replacing bytecode with C code. That's not a big deal. So there were lots of difficulties in making Nuitka. For example, the frame stack that Python maintains with locals, globals, and these kind of things. That's terribly difficult. There's this exception handling, which has very interesting semantics. I can never remember what the cause or the context of an exception is. I always have to look up what that is. And this is very detail-ridden stuff. So, but making this transition to static compilation, it's actually something simple, and I don't recall right now, but Nuitka may not have been the first to do that. I'm not sure anymore. But the dynamic nature actually is a non-issue, because I have this pi object everywhere. That's not making it harder. That's making it easier, right? Because I only have one type. This Python has just one type, and that's one C type of a pi object. That's not. It's easy to assume that must somehow be harder, but it's not.
That's definitely very interesting, because, certainly my assumption going into it is that because of the fact that you can assign different types to variables would make static compilation more difficult, but as you mentioned, having a single C type simplifies things a lot.
Yeah, and then the CPython type system is designed to be extensible. So it's pretty easy to put in your own types. So once we work with these, what other people call boxes, right? These pi object. There's a lot of overhead involved in having these boxes. And I certainly want to get rid of these soon. For example, do float calculations locally on the stack. But being allowed to have it is not a complication. It's simple. I just made one plus. I made one minus implementation. There's not a lot of performance gain that you can expect from that, but with a few tricks and stuff, relatively quickly a 2 to 3-fold increase was achieved. So even without any type inference and stuff, it's easy to become faster and then gain some extra percentages from avoiding checks here and there. So this part of the project was easy. The really difficult stuff for me was to represent that relatively dynamic control flow in a structure that allows me to have a single state assignment, and to make that transition, because originally I had just something that sort of I had a node tree that happened to generate the correct program, but when I was walking my node tree, I just had it was not abstract execution is what you want to do when you do this walking. And in many places, abstract execution was not yet feasible because this structure had to be broken down into something else. So it took me a long time to get just that correct. And I was doing a lot of refactoring. And every time I completed, I had a compiler that was just about as good as before, but one step closer to where I am now. So So with this next release that I'm bound to make maybe this week, I have this fully solved, and that's many years long effort to get from something that was more like a templating mechanism to turn the AST into C++ to something that is an actual compiler. So for a long time, I wasn't thinking of Nuitka as a real compiler. I would write many blog posts and say it's not a real compiler yet because it cannot do this. It doesn't really understand the source code. It's just I would have to limit it to certain optimizations to certain things because it doesn't understand things properly. And now I can have semi-complex functions and inline them to nothing because I understand these things. And that's a tremendous step ahead. And that was the difficult stuff. And the difficult stuff that didn't have to do anything with types. It was with try finally is just horrible. And that's why some languages don't have it. So, and especially not at the same time as try except. So it's it's very convenient to the user, but
the implementation is less than pretty.
Horrible. For example, if you have try return 1, finally return 2, what do you think is going to happen?
That is a very good question.
Yeah, I don't know right now. Nobody knows right now.
I'll have to try that.
A return statement in Python code is just a proposal. You can, at any time, you can turn this into a break of a loop, or That's just insane. And yeah, the control flow is much harder of Python. Actually, I can easily write code that you cannot predict, and it's short. And that's I learned of some of these things. For example, my first versions, I used the C break statement in a C loop for the break statement. That was until I realized that that's a break statement has exception semantics too, and it can be caught by a finally statement, which then can do something else. And there's actual code out there which does this. That was really the biggest challenge to me. Also, the many details of Python, it's insane. So when I was working through this, I was working through the test suite of CPython, and you have this test ABC, something like that. I was going by the alphabet, and once I passed test grammar, like there was test compiler, I had learned so much about Python already that I never thought possible. So there's really it's also very detail rich. You wouldn't expect that. Although it's a very uniform, everything feels like a dictionary, and Python feels very homogeneous. Python 2 especially has a lot of tricks up its sleeve. For example, I doubt that many people know about lambda functions that can be generators. I didn't know that. So you can write lambda brackets yield 1, or you can write lambda yield 1 comma yield 2. And that's also very hard to predict what these things do.
So that actually brings up another question, is what support Nuitka has for Python 2 versus Python 3, and also the different point releases within those.
Actually, I support, I'm trying to be compatible with all that I've seen. I originally started, I think, against Python 2.5, but I eventually dropped supporting that. There was one good reason, but I'm supporting Python 2.6 now, 2.7, 3.2, 3.3, 3.4, and the just released 3.5. I've made a posting on my site and explained some details on this. I don't yet support coroutines. That's the real big new thing that Python 3.5 has. Mm-hmm. And I will get to do the catch-up game and implement a compiled coroutine code eventually, but I didn't get around to that yet. So, but other than that, Python 3.5 is supported, and sometimes even minor changes between 2.67 and 2.68, Nuitka will behave the same way the minor version it is being run with behaves. So it's easier for me to I'm just for tests, this is a dream project because I have this perfect oracle. So I have a CPython implementation, and I will run a program with that, and then I will make Nuitka behave exactly the same way. And oftentimes it's much easier for me to just add another detail or even a minor version difference, just so I don't have to write something else that whitelists some tests as being allowed to fail. So that's I'm writing in the documentation. I'm saying absurdly high compatibility. So it's insane. It's almost like I enjoy this kind of puzzle games. So I also got into the crazy mode of compatibility at one point, I suppose. So it's just like I don't know. I've added compatibility for things that I was initially thinking, no, I'm never going to do that, and eventually I did. It's also there's some fun to that. It's like a zen.
So your comment about not being able to support coroutines yet leads me to my next question as to whether there are any particular Python constructs that Nuitka is unable to translate, and also as a corollary to that, is the compilation step lossy at all, or do you have some way of ensuring that the functionality of the program remains unaltered after it's passed through Nuitka?
No, I'm just running a large amount of tests on this. I actually, this year I've I've burned through my desktop. It's kind of gave up, and I burned through quite a bit of hardware now. So I'm running a lot of tests. Testing a compiler with continuous integration is kind of CPU intensive. And I'm running programs. So, for example, the CPython test suites from 2.6, 2.7, 3.2, 3.3, 3.4, and soon 3.5. I'm running those, and then I'm running Mercurial, and I'm running test suites of some programs, and then I'm compiling Nuitka with Nuitka, and the compiled Nuitka compiles Nuitka again, and then the source code is supposed to be the same. And these kind of things. So I'm doing a crazy amount of testing, and it's pretty much feasible to do a crazy amount of testing. And I have a lot of exposure by users now. So I get reported even very small incompatibilities, and I fixed these for some years, and basically just stopped. I think I've overseen a Python 3 feature recently. So there was something, some form of complex assignment became possible that I just never encountered anywhere, but somebody read it from a PEP and wrote it. It wasn't in the CPython test suite, so I'm not guilty. But it's very rare now that something is not behaving the correct way. So it's much easier than I thought to achieve a high level of compatibility. I think once I start to do this type inference thing, I am going to be in more trouble. Because right now with this, everything is just that one object type, and compatibility is much easier. But once I start to replace locally the float CPython, libpython implementation with my own one, there's all sorts of possibility of getting that wrong. That's and then only some code will run more optimized or less optimized, and the value of this Oracle testing will diminish. And what I will do, that's a plan, is to ask people to integrate that into their own continuous integration setups. So I'm going to add support for TOX and PyTest. And then it should be easy for people to just run their test suite. And that's hopefully sufficient to give us the assurance that a sufficient amount of code is running through this to remain sure. I have always strived to be correct, so that's probably my background is with this ATM. It's correctness is king, and this is really where I wanted to be first. Instead of being fast, to me the interesting question was, can I be correct? And so I was aiming for correctness first and performance second. So that's I think it's a good spot to come from something that is working, making changes on that. As everybody knows who's doing continuous integration is if you have a good test coverage, that's going to help you avoid false decisions. So what's not working? That was the question, right? So I got a bit distracted. So the thing I am not having is I'm not having bytecode. So the code object of compiled functions is empty. And that also means you cannot attach the Python debugger, so PDB. It's mostly useless with compiled code. And to me, that's a big point of Nuitka, was that there should be no price attached. So I've strived to make sure that nobody's supposed to change the program in order to support Nuitka. So that's it's the other way around. And that's working. And the code objects and the flags on that, and all the details that are actually used are there. So it's a serious bug if the software doesn't run out of the box, and Nuitka is being exposed to much code. And I'm usually the default report. It just works.
That's definitely a good way to help encourage adoption, being able to say you don't have to change anything about your code, just pick up Nuitka and start using it. So
beat that. I mean, I'm not. Performance is my weak side, which is sort of ridiculous, isn't it? Mm-hmm. But I was not convinced that people can use a compiler for serious stuff if they cannot be sure it's correct.
Yeah, you definitely need to start with making sure that things work, and then you can work on making them work better.
Yeah, and it's very, the industry I'm working with is very conservative, and I wasn't going to have benchmarks at running at lightning speed when I perfectly know that later on I will have to make changes. I give up on that. So that's probably I would have more contributors. Yeah, it's part of what I am.
And so, are there any particular types of programs that benefit most from Nuitka's compilation?
Yeah, surely. If you're CPU bound, that's clearly a prerequisite, or you should be latency bound. So if sometimes you have a program which wants to be real time, soft real time maybe, and still be Python, and then the Python runtime, even if you don't run in a loop, you just want to finish as soon as possible, then also compilation can of course be very useful. Scientific programs are my most obvious goal. Once I am capable of doing this type inference and have dedicated code for float, I think NumPy allows people to write most of their code in something that will be executed in C extension code. But the part of the program that you write, it's written in pure Python. So here's one callback that's being executed for a matrix. That's the part where you get slow, and the idea is to integrate there and to make this C speed. So once that would be in place, and I'm hoping for somebody, university, some professors to work with me and students there maybe to do some integration there. That would be an interesting goal. And then where I'm coming from is what we did was bindings with C types. And I think PyPy created CFFI, which is also a good idea. And what Nuitka should become able there, that's my next goal actually. My first goal, what I want to do with type inference is to make a demonstration of zero overhead binding. So I want to make calls into say libc or qt or whatever it is, and demonstrate, look, you can do these with C types bindings, you can do stuff. And yeah, it's just as if you had written a C. If I manage that, I want to get offers of bindings to use pure Python for their work on creating bindings, and move this into this Python world, allowing for better optimization. That's one of these immediate goals. That's the programs I'm aiming at. Largely, scientific community is very interested in Nuitka. Financial industry, pretty similar. I don't have much contact there, but I get that they are using a lot of Python data analysis too, and that could be run faster out of a box, right? So that's definitely interesting. I think the normal program that you and I write, even Nuitka itself, won't benefit as much. Although Nuitka obviously is going to be more CPU bound than other programs.
And your comment about the possibility of using Nuitka compiled code for supporting soft real-time systems reminds me of the fact that you mentioned you had spoken with Damien George of the MicroPython project, and I know that he's currently working with the European Space Agency to try and see if MicroPython is something that would be feasible for use on equipment used in interstellar missions. And so it sounds like Nuitka and MicroPython would be a perfect combination for that type of project.
I think MicroPython might be. I'm a huge fan of MicroPython. I talked to Paul Bodie in emails years ago. We eventually stopped because I reckon that we were having very productive discussions, but I was like discussing Nuitka in a distant future, like to where I'm now. So where I'm now was sort of a prerequisite of what we were discussing, and there's a lot of common ideas and ground there. The thing is that MicroPython is I think geared at being a tailored solution, and is not going to benefit from the whole Python ecosystem. And it will fit into small hardware and stuff. And what I'm looking at is probably more like, well, you could maybe it's more for the smartphone sized embedded hardware if you want. I don't think MicroPython is going to be more suited to that. If you want to have these soft real time, I think you're going with MicroPython, right? But that was just generally a comment of where it could provide benefits. Obviously, if you really were into real time, you probably shouldn't use Python, right? You should use MicroPython or something else.
Mm-hmm. And so I'm sure the one question that our listeners are most anxious to hear is how Nuitka relates to the GIL, and if there's any possibility or future plan to produce compiled code that makes threading and usage of multiple processors easier without having to make any large changes to their Python code.
Yeah, I'm already having this crazy idea of creating this Python compiler, I have this other crazy idea that static analysis should, together with something I was going to talk about, profile-guided optimization. Recently, I was thinking no, if you give me these tests of yours and let me run it, so that's how profile-guided optimization works. You collect at runtime type information. What maybe the way and the order you access things, and it could be possible to identify parts of a program that do not overlap in your test setup. And doing that, we could guard the access of across the boundary of these with locks, finer-grained locks that cover these sets. And with the help of user annotation and profile-guided optimization, we could identify the few spots where things that are GIL affecting happen. And I contend that it's possible to get, even with CPython, a parallel execution. You just have to avoid the memory allocator. The memory allocator must not come into play. So internally it uses a cache of things, and once you run into using and interacting with it, that's going to be painful. But there was also a PyParallel guy who had a working prototype of speculative execution. So it's basically along the line of software transactional memory that the PyPy people contend. You can observe what the program does, and then we could generate code that makes the actual conflicts manageable. It feels like, at least for benchmarks, it's going to work pretty well. I don't know how it works for real-life programs to do this, but if you're really interested, I see this on a very distant horizon of Nuitka. So I don't know if I ever going to make the Nuitka that I want to have, but I know that if it exists, this should be possible. But with a GIL, it's like it's like these things, like it's like a Python compiler. Everybody thinks removing the GIL is possible, but nobody's doing it. That's unfortunately so. So I've been to presentations of how the GIL could be removed I've seen these for years now. Nobody's doing it. So maybe eventually, if I live long enough, I will do it. But just in this, just tailor to your program static analysis, and I think profile-guided optimization. I can compile a version of a program that will tell me about all sorts of collisions. So you run it, and it will tell me about the collisions, and you run it, and each time it's running, it can feed me back with possible collisions, and ultimately that may result in a data set that is workable for this. So, but it's insane. And I mean, really, if I were to listen to this, okay, so this person tells me it's going to create a perfect compiler and solve a GIL problem after dinner. I'm not trusting it. Like originally when I was thinking it should be possible. I think I have a good track record in the offline world, which is not visible outside of Nuitka. I have a good record at when I think something is possible, most often I can do it.
Yeah, I remember reading an article a little while ago about somebody who several years ago actually succeeded in removing the GIL from Python, but because of all the additional checks that they had to put in place, the resulting code actually ran about 2.5 times slower than when the GIL was present.
Yeah, but that was on a single core. And I think originally, Guido made the decision to not sacrifice single core. And also very understandable. The thing I think I can perfectly sympathize with Guido there is that he created Python, and Python is also something he did, right? So it was something that he thought could exist, and he just did it. And beautiful, it's simple, and not having the GIL means you have to be a lot more complex in the code. And I also think, rightfully so, the Python core community or Guido didn't want to have that complexity without. I don't think Guido is all that convinced that Python has to be fast. For him, it was like there's always C if you want to be fast. So, and he's right about that. But it's I want to move it out of that box. But technically, the GIL is only a problem if you want to be fast.
Certainly.
And nobody needs that.
Is it possible to feed an entire project with multiple modules into Nuitka all at once, or is the standard use to perform compilation in one source file or submodule at a time?
That's too tedious. So one thing I've learned over the years is also that it must be usable, or it's not used, and it's ridiculously simple to use. So you would say Nuitka main program.py, for example, user bin hg mercurial. And then it will ask you, well, yeah, I just compiled HG, but I'm not recursing to the Mercurial submodule. Please add the following options to do that. And then you will say Nuitka recurs all user bin HG. And then it just abstracts, executes this main program, finds the import, follows them. And wow, it's an incredible amount of work to have to get that compatible. Originally, I was using Python code for that, but turns out that that's not compatible enough. So I got to re-implement this whole thing, and it has a lot of details. For example, case sensitivity and order and stuff. It's really relative absolute imports. It's very confusing. Actually, every time a bug is found, I'm shocked, and I know it will take me literally 2 days to understand what this is all about. But it just works. So I have multiple modes of operation. You can compile a whole program. You can compile a single module into an extension module. You can compile module and other modules or a package into one thing. And basically all the modes of operation imaginable are possible. One popular mode is also something called standalone. So when I compile, I see this mostly as a means for acceleration. But there's a world of people who think that the compiler is also to take a binary and put it on another system and have it work. And standalone does that. So essentially it creates a mini distribution of Python shared libraries and system DLLs. and you can copy this to another system and it will just work. That's also a very popular use of Nuitka for distribution. Although I'm pretty sure there are other options, CX freeze or that sort of thing, which are also good. But it seems like people like to use Nuitka for that. So what Py2Exe once did. I think Py2Exe may not support Python 3, but it's ridiculously easy to use.
That's great. So I'm curious about what led you to choose compilation to C++ for Nuitka rather than making Nuitka an LLVM backend like Numba.
Yeah, I was thinking of that too once. The thing originally I explained is I wasn't going to start the project if I had to do the later thing. I just wasn't going to do it. Doing that C++ macro, so I would literally write a code chunk in C++ with classes, with destructors doing all the things automatically. So, for example, releasing objects was just something I didn't care about. I would have a local variable class and a temporary variable object class, and they would just do that. And I would fit just expressions into the with template, and things just worked. And that was very, very easy to get started. And an LLVM backup, on the other hand, wasn't going to be that easy. So I wouldn't have had destructors of C++ doing things for me. So it was also about it was going to be a proof of concept. Later, when I revisited the decision what I want to be, I thought that C is already relatively low level. So I wanted to also have, for example, C++ exceptions and that kind of thing. It seemed a very good way to start what was already an ambitious project to make this compatible Python compiler. And later, C just seems like close enough to the end language, but not being dependent on LLVM. I don't know if you ever heard of the Unladen Swallow project. I'm not sure I'm pronouncing that right. That was Google's Python compiler. I didn't get to talk to a lot of people about it yet. It just died, and it died from LLVM bugs, and it died from it was just being dependent on one compiler it's a risk, and with C code I can go wherever Python is. So now I am not dependent on any particular backend. There's also some prices to pay to support the Microsoft and GCC and LVM C code, but in theory it's pretty low level if you write. It's easier to read, and I know how to do that. So
that makes perfect sense.
I'm not sure. I'm not sure if that's the best decision. I thought about it. I probably just because I saw Cython, I thought it's nice to have a source code and be able to edit it and save and run it and see if it's any different. I don't know if the LVM bytecode approach can also do that. I just don't know.
Right. And it makes sense, actually, hearing you speak about it. I can see that having that extra abstraction that C++ gives you would make building the project that much easier. For one thing, I mean, if you are already a native C++ speaker, then there's no reason you shouldn't make use of those abstractions. So that makes sense even in and of itself.
At least to get started, right? So, and from there, I'm gradually migrated to something that is now much closer to the LVM bytecode maybe. But for starting out and having something that is actually working and having that, it didn't take me that long. I'm doing this in my spare time, and maybe 1 year later I was having it, or maybe less. So it's definitely, it was attractive to have this gradual migration. So even if I now have go-to written C code, you could be better about sequence points. You could be a bit more optimal with this. Yeah, maybe one day somebody can change that. It's definitely, the code generation is getting stupid enough for this to be done by whoever wants to at some point. So code generation, I envision that at some point somebody might also generate Python code from Python. That would be a cool project if somebody wants to take on that. So taking complex Python and making a more optimized Python version out of that, then you do not have any drawbacks of compilation. That's the kind of thing that I would like to see ultimately. It's the code generation is getting incredibly thin layer now, with becoming easier to replace us.
Yeah, I wonder if in the future it would be possible to even create a backend to it that does code generation that outputs Rust code, for instance.
Mm-hmm. Yeah, I mean, I'm going to mention PyPy later on, but ultimately it would be cool to have this. But maybe when the project advances, that's going to be possible. But you have to be aware, for my graceful degradation plan, you always need libpython. So, for example, JavaScript in a browser, that's not going to happen. PyPy was going to do that, or did that actually, or does that. But for my graceful degradation, there's always going to be some percentage of a program that is going to run in libpython, just because it's too unimportant or something, or too difficult or too complex or too confusing. And I will never have a complete replacement for libpython. That's not going to happen. It's always going to be an accelerator around libpython. And then going to a whole different runtime. Maybe it's possible to have libpython and Rust at the same time. I don't know.
And so how does Nuitka compare to projects like Numba, Cython, or PyPy?
Well, Number and Cython, right? I have this graceful degradation goal that I mentioned a couple of times now. So basically, Cython doesn't intend or want to be compatible or capable of running your whole Python stack. It wants to do the job that it's aiming at, writing extension modules in a language beyond Python. It does that pretty well. I think it's a tool I would recommend if you want to be fast and use Python now in code you write. So I would recommend Cython for that clearly. Number is something that I've not ever used, which is probably a shame, but you have to be aware that I'm doing this as a spare time project. So I learned of it at some point, and then I was told it is a JIT, and maybe it now does static compilation too. But the thing that immediately put me off is that it's not going to be fully compatible. So there's not this graceful degradation goal, but it's just some sort of Python code that works in somehow different ways. So it's not going to give us the whole Python stack. And I think that's, I'm not against multiple projects. I know that some people tend to think that other projects shouldn't exist. I'm not that kind of person. I'm for plurality, and I think we better bet on multiple cards. So I like every of these projects, but I would like to have something with a zero cost and full compatibility goal, and rather integrate with these two. Which it does, by the way. So in a typical Nuitka compile program, there's going to be a lot of Cython compiled SQL. Yeah, that's definitely one difference is that you cannot throw Number on your million lines of code program unless I'm mistaken. I don't know. So I never looked at what it's actually producing when it compiles. So that brings us to PyPy maybe. PyPy is something that deeply impressed me. I think it's the coolest project ever. I told this to the PyPy people every time I meet them. It's definitely cool, and I was contributing to it even at some point in very small ways, ridiculously small ways. I was just making minor fix-ups for my use cases. But they share the pure Python goal. So what PyPy really want to do is also carry a full load of being capable of everything, except that they don't really. That's also the idea of why, and the fundamental difference of JIT compilation versus static compilation. I chose to think that you will always be limited in what you can analyze at runtime, and there's only so much to gain there, and that the ideal approach will always be a hybrid. My secret plan, profile guided optimization, should actually make me competitive with a JIT. The JIT has this warm-up phase where it needs to find out what's happening before it's actually speeding up the program. And profile guided optimization is like doing that and then saving the result and using that for static compilation. So I think on benchmarks at some point Nuitka will hopefully be able to outshine PyPy. Definitely not the case currently. I think if you want to have fast Python, pure Python, I would recommend everybody to go with PyPy currently. I mean, like literally, that's I think the best options if you can fit within their constraints. I think the amount of hardware platforms it support is limited, and Python versions is limited. They don't do Python 3 latest stuff. I think 3.2 or 3. They somehow stopped at some point, and yeah, it's also a slow-moving project. But they share my goals, so but it's radically different. And the other two, they're kind of more like niche solutions, but maybe that's also why they become more successful ultimately. I think that Number and Cyton totally have a potential to always be the go-to solutions for fast things, and I might just come too late. So that's how I would compare. The thing is, Nuitka is definitely something that is maybe getting ready, and Number and Cyton and PyPy, these are things people actually use today, and rightfully so. So I have these users, crazy people, but I have no way of demonstrating, for example, how fast I am.
And so how can users evaluate the performance of Nuitka to determine whether they should use the output of Nuitka or if they should just continue using their Python source code?
And so except for the good news that function inlining is now about to work and stuff on EuroPython, basically I presented this as my hugest problem, is that you just cannot. So people use this and find out it's good for them and then they use it. But it's very hard to predict though, because I have reports from other people who use it and tell me it's slower. There's also one guy, I think pythonperformance.org.com.net, I don't know the exact address. There's one guy benchmarking different compilers against each other. And Nuitka is not comparing favorably to Cyton all the time. Sometimes it's slower, sometimes it's faster. And that's something that clearly needs to change. I have looked at some benchmarks and made some things fast, but there's definitely things lacking. And so my goal is to develop a tool that compares CPython and Nuitka runs. So you would run your program with CPython, and you would run your program with Nuitka. And it's based on something the PyPy people did. So I was presenting this as my problem, and actually on another day, the PyPy people presented sort of what the solution is. So they developed, and I think they have the same problem, is to compare their implementation to the reference implementation. So they developed VMProf, which can analyze CPython performance against PyPy performance, or after my work, I can also compare it now to Nuitka performance. It's not yet pretty, but I'm working now on a tool that people can use to run it and then turn this into a bug report. Look here, this function, Nuitka is slower there. And then I can change that and be more consistent about speed up. So right now I have maybe 2 to 3 for some code and minus something for other code. That's not a promise, right? So I'm not promising that. Or at least I try to. Of course, there's always a temptation to say it's good. And that's to be done. I was asking for help. But, I want to have help with that, and basically doing benchmarking and performance and all these sorts of things. that's a tremendous amount of work, and surely I need help there. But I'm going to work on this part real soon now. So I'm going to make some type inference stuff, and I'm going to make this tool. This is where I want to aim at. And then I think I will have something that is entirely new, like something that can help me to work with people who encounter performance issues with Nuitka, or for people to evaluate comparatively what is it going to give me exactly, and where is it going to give me that and where not. That's great. So I'm only starting to get serious performance now. I have a link in my article on the site where I have a 20-fold, 10-fold, 20-fold, I think a huge increase in some constructs already. A lambda function whose inline gets inlined. The thing that will happen more regularly when I get the function inlining operational. That's the amount of factor where I want to be. But the compatibility, there was such a high bar to take that it's literally took time. Then some of the easy early decisions that I made, C++, 11, C++ exceptions and so on, getting away from that gradually, that also took a year. And then the single statement assignment, so basically from the first version that I presented to what I have now, 3 years later, to EuroPython 2012 to 15, I was working on this, and it wasn't complete 3 years later, but only now. So more than 3 years of gradual work to get that working. That was a long time, and also, it's kind of terrible if you make a compiler and people are asking you, but how good is it? What does it do? And stuff. And you get to pick. I got to pick. Do I document how bad it is, or do I improve it? And I tend to just improve it and ignore requests for this performance stuff, comparative performance stuff. And but now I'm going to use this because now I can finally turn to performance, actual performance. I used to be making performance optimizations like most of my jobs so far, and not as much in the last one. That's maybe also why I started Nuitka. And I'm pretty sure that I can make some quick progress in the next year. Yeah, but to answer your questions, they currently cannot evaluate the performance of Nuitka except for compiling and running their own programs and benchmarking that. That's about it. And if it's not a good value, there's no way of telling why. That's the problem I need.
Well, before we move to the picks, are there any other questions that we didn't ask that you think we should have, or any other topics that you want to bring up?
I want to highlight the fact that I'm doing this on my own as a spare time project, and I'm not against working with other people. I feel like I'm not hard to work with, so I definitely want to have people join me. Also, I would like ask people to. I have donations. I'm not asking a lot for donations, but I'm giving all of my spare time to the project, and I'm also having hardware costs, for example, having to replace my desktop, or my keyboard on the laptop recently broke for the second time, just because of wearing off. And that's, if people were giving me a donation, that would also be validation to my wife that this is somehow worth my time. And so that's... join me, help me, and I think to me this is all what I was hoping for more. I was hoping for people to join me with this. It's not PyPy. It's not the coolest project in the world ever, but it's not that far away from it. If you want to join it, we can make it. We can make it also cool ways. I am having a plugin framework added recently, and I put some hopes on that. So There's now a plugin, for example, which does handle multiprocessing module on Windows and apply some hacks. And it would be possible to do plugins which transform the source code as it gets compiled. Plugins that will be able to monkey patch compiled code, inspect things, change things, hint types. This will be, I think, a fun area to work and expand on. It's a sidekick that I'm working on, and I'm hoping that this will expand things, and I'm hoping that people will join and enjoy that. But really, I'm almost feeling like a crazy person doing this on my own as the only one. Sort of help me stop that. And not by stopping Nuitka.
All right. Well, thank you for all of that very interesting information, and I'm sure our listeners will appreciate that as well. And to any listeners who have the skills or ambition to take part in the project, I definitely encourage you to do so, because it seems like there's a lot of promise there.
Yeah, it's a promise, and I've done the groundwork. The fun is about to start.
So for my first pick, I'm going to choose a board game that I got recently and started playing with my son called Forbidden Desert. And that is actually a sequel to the game Forbidden Island. And they're both cooperative games where you are trying to move around a grid of tiles. And as the game progresses in Forbidden Desert, there's a sandstorm raging that will push the tiles in different directions and bury them with sand, and you have to try and excavate the ruins of this ancient city to find all of the parts of a flying machine so that you can escape the city before it gets completely consumed by the sandstorm. And so it's just a really interesting game mechanics, a lot of fun. It says recommended ages of 10 up, but I've been playing it with my 5-year-old and he loves it. So definitely recommend checking that out, as well as Forbidden Island. And for my next pick, I'm going to choose the Auto project from HashiCorp that they just announced as a replacement for Vagrant, and it's intended to simplify creating development environments and then promoting those up through to production. So I started playing around with that a little bit. I've been meaning to spend more time on it, but it definitely seems like it has a lot of very interesting ideas, and it's pretty intriguing how they hook that into a lot of their other projects that they've created, such as Console and Terraform, for being able to build and release onto production infrastructure. And with that, I will pass it on to you, Chris.
Thanks. My first pick is a beer. I have been on a Grim Brewing kick because they are awesome and they produce really unusual beers. This week's is called Grim Supersymmetry. It is a dry hopped goes made with lemon zest. And as I said, they just create these beers that you look at them, when they get poured and you're just like, that's going to be interesting. And they have a really interesting nose and really interesting flavor. This one has just, a little bit of sour tartness and you can taste the lemon zest. It's a really good beer. My next pick is a really interesting website. It is, I love to work with this on in the background. I know it's going to sound like an odd mix, but it plays sort of ambient electronica with, in the background, they have the Boston PD dispatcher and police radio overlaid over the electronica. And so what you end up with is this really kind of interesting, surreal mix of ambient music every once in a while punctuated by a radio exchange. And I think it's great to code by because you occasionally get that minor distraction that catches the 3 brain cells that need distracting off guard long enough for you to actually able to, take a breath and finish writing your code or whatever. It's really neat. So I highly recommend it. And my last pick is a currency for value exchange. I refer to it, don't refer to it as a cryptocurrency only in that it's not really meant to be used like Bitcoin or anything like that. It's called Ripple. And what makes it really a lot of really interesting technical aspects to the way it's built. It does not use proof of work. It uses basically, various nodes in the network need to agree consensus. That's what it is. Sorry, brain fart there. And the reason I'm mentioning it, aside from the fact that it's technically interesting, is that 5 of the world's major banks just agreed to utilize it as a standard so that if you make financial transactions at one bank, it will go over their private Ripple network to the other bank. And so interesting stuff. And that's it for me. Kay, what do you have for us?
Yeah, so one thing I clearly want to point out is that I've talked to a lot of Python implementers, and MicroPython, I think that's really the most impressive thing to me. They have a lot of science. I talked to this Paul Bodie, and I listened to your podcast from Damien. Very interesting stuff, and I would recommend everybody to look into this. It's much more than I initially thought it is. And there's a lot of clever ideas in there, lots of which I got introduced to and will be using, and I think that will help make Nuitka unique. And the other thing, one thing that changed my life quite a bit was applying skeptical thinking. I at some point ran into the atheist experience, and from what they call a deist, I turned into an atheist, but that was only a side effect of what they really do is to teach you to learn skeptical thinking. And that's something that made a deep impact into lots of ways. We always tend to be hopeful and thinking and assuming things to be true without good reason. And that's a general principle. And I've learned that even as a technician, you need to be very skeptical before you believe something to be true. And that's, I would recommend everybody to check that out. It need not affect what you believe, but I think it's very important to learn to have good reasons to believe something. So that's what I think is interesting, and it's something that I encountered. Yeah, and I would like to thank you. I don't know. I'm probably going to get for having me on. I've seen the list of speakers so far, or interviewed persons so far. It's a great honor to be on, and really enjoyed that. And I definitely found what I've heard of you so far very interesting. So thank you for having me.
Well, thank you for taking the time.
Certainly. And hopefully we can get you some better exposure and get some people interested in helping you out with the project.
This is a very easy way to get across a heavy signal message to your listeners. So that's I appreciate the chance to get that exposure.
And so for anybody who wants to follow you and the Nuitka project and keep in touch with you, what are the best channels for them to do that?
Follow nuitka.net, of course. I have a blog. You can subscribe a feed. Then, of course, I'm on Google+, but I'm not sure, plus Kay Hayen. I'm not sure that's going to live for very much longer, right? So I don't do much social stuff otherwise. So and even then, I only very occasionally post something on Google+. I'm reachable via email. If you have a question, it's on my website, k.hayen@gmail.com. I have a very liberal policy. Everybody gets to write me, and I answer even stupid questions. So it's so far I can do that. So if you have anything or want to get in touch, or if you want to make my days, there's been people who just send me emails letting me know that that it just works and they would like to thank me. That's a great way of making my day.
We greatly appreciate you taking the time to join us and speak with us today.
Thanks. Bye-bye.
Thanks. Bye-bye.